cut my answer short for two reasons. One, because of time, and two, because it was a difficult question. And introduce Pete, who I've actually already introduced. So without further ado, thanks, Pete.
Thank you, Andy. Cheers. So I was the convening lead author of the Chapter 6, which is the one that tried to integrate all the stuff that you've heard already. So the desertification, the climate mitigation, the climate adaptation, the land degradation, and trying to pull this, and the food security, trying to pull this all together. It's very much focused around the solutions. So this was the sort of solutions chapter, and I'll also give you some of the material that was covered in Chapter 7, which is how you organise the policy to try and deliver this stuff. So you've heard a lot about the problems so far. What we did in this chapter was put together all those different response options that have been proposed to deal with any one of those things and see how they co-deliver across all of those different challenges. Yep. Cool. Other way around, yeah. Okay. If you don't remember anything, this is the takeaway message. The takeaway message is that land is under growing human pressure, and also additional pressure from climate change. We've heard that quite clearly from the other chapters. Land is a part of the solution. I'll come on to that in a moment. But the other thing is that land can't do it all. So unless we do mitigation in the other sectors, emissions reductions in the energy sector, the transport sector, the building sector, and we leave too much to land, then that's going to leave us in trouble because of the fact that we've got this very limited resource. So whilst it is part of the solution, we can't rely on it to do it all. So the land has to form an additional thing that we use to mitigate climate change, and we use to adapt, and we use to deliver food security. But it can't do everything. It can't do what we need to do in all of the other sectors. So it has to be on top of immediate and aggressive emissions reduction. That's the bottom line. Land can be part of that, but it's not a substitute for that immediate and aggressive emission reduction. So as I mentioned, we looked at a bunch of response options. So what we've got here are the sort of sustainable land management options. Some of those in agriculture, some in forestry, some that are soil-based, and some that cut across ecosystems or rely on other ecosystems. We've got some response options largely that are proposed to help deal with sort of food security, to help improve food security, which are based on demand-side measures, which Andy's talked about a bit, and also some of the supply-side measures in the value chain. And we looked at how these co-deliver. And then there are some response options based on risk management, largely sort of social and governance issues, things like risk-sharing instruments. We've actually looked at 40, so I've just listed around about 28 here, because these are ones where we've got good global data for all of them. We originally had 42, which is a magic number, as you know, but a couple of them got merged and we came down to 40, which was annoying. So Andy's already put this horrible slide up. I don't want you to look at the detail, but when we started doing the analysis, when we started pulling this together, we were looking at what's the impact of these different response options on mitigation, adaptation, desertification, land degradation, and food security. So when we started putting those global numbers together, we thought that we would have a mix, right? So we'd have a bunch of co-benefits, which would show up in blue, and we would have a bunch of trade-offs where things aren't working very well together, which would show up in red. What we found when we started putting the information together from the other chapters and from separate analyses is that there's a whole lot of blue on there, much more blue on there than there is of red. And that's the sort of good news story of the report, in that many of these response options, be they based on sustainable land management or through interventions in the food system or through some of these risk management measures, actually deliver very well across a range of these options. So the blue ones are the ones that are co-delivering. So if you've got blue all the way across for a different response option, then it's delivering well. The darker blue, then the higher the contribution to those specific challenges of mitigation, adaptation, food security, etc. So we've got some dark blue ones there, so the increasing food productivity, which we would do through sustainable intensification. This doesn't mean throwing more and more chemicals at the system. That has to be done sustainably. So we're increasing productivity. And there are large areas of the world where the production is way below the biological potential to produce. So it's closing that yield gap through sustainable management rather than just artificially propping the system up. Agroforestry is another one that shows up, having co-benefits, large co-benefits across all of those. Increased soil organic matter content, again, dark blue all the way across. And then we've got some other options which are blue all the way across, and I'll talk about those in a moment. A couple of missing values here where there's no global studies, but dietary change and food waste reduction are really important, and they're important not only for delivering across each of these challenges, but also because they take the pressure off the land, and we'll come back to that in a moment. What's shown on the right-hand side are 6 of those options that have just been pulled out because they do have some significant red in them. What's the common factor among these ones in terms of bioenergy and bioenergy with carbon capture and storage? Reforestation and forest restoration, afforestation, and the use of land to grow feedstock for biochar, which you then add to the soils, is that they potentially compete for land on food security. So the one that pops up is the food security, and this is always occurring because of potential land competition. So if we decide to grow an area the size of India as trees or as bioenergy crops, that's an area the size of India that we no longer have for food production. So that's where we start to run into some of the issues. What we've got on the top is that assessment at the global level, but what we've got here is we're just showing how you could mitigate that. So what's come up a few times already is the context specificity of a number of these interventions. If you do them, you can do them badly. You can do them very, very badly and get them very, very wrong. But there are cases where you could do these all sustainably. Obviously, forest restoration and reforestation does not have to impact food security. In fact, there are examples, for example, the large afforestation program in China has reduced soil erosion, it's improved water quality, and actually not on the same land, but on the other land where that erosion has been reduced, it's actually increased food productivity. So even with these ones that have potential issues associated with them, and you can't say, just go away and do it, everything's going to be fine, you can find situations where all of these work, including bioenergy and BECCS. And this argument's often characterized in terms of bioenergy is a bad thing because it's going to compete with land. There are places where you could do this integrated into a sustainably managed landscape where it would make perfect sense to do that in addition to food production. So it's not quite as simple as saying there are good options and bad options. Many of them are context specific, and there are good ways of doing them and good situations in which to do them, as well as bad ones. But these ones over here on my left, your right, can't remember which way round I am. These ones over here, these are the ones which have largely co-benefits and co-deliver across all of those challenges. This is what it looks like. So this is just showing if we've got a red value, the darker the red, the worse the issue. The darker the blue, the better the issue. What you won't be able to see, I think, is some of the values in here. This means low, medium, or high confidence. And at the global level, we've actually got relatively low or at best medium confidence for a lot of these, because many of these interactions haven't been studied. So this is the first time that this has been pulled together for this IPCC report to consider all of these things together. So there have been a few studies looking at adaptation and mitigation, a few looking at desertification and land degradation, a few looking at mitigation and food security, but not many that look at them all together. So what we need to do moving forward is we need to find better ways of integrating all of these things so that we can look at them in an integrated way and look at the trade-offs as well as the co-benefits between them. Okay, interlinkages. That's the last nerdy slide and the last one that you won't be able to read. All of these things are interlinked, and some of these are more effective when paired. So a good example for that is waste reduction. About 30% of the food that we grow on the planet is wasted, either pre-production either in the field, which is largely in developing countries, or after harvest in the sort of consumer and post-consumer phase. So that's 30% of food that we grow that we waste. So reducing that actually takes pressure off the land. So if we were reducing less, say we halve that waste, there's irreducible waste like banana skins, which we can't eat. But if we were able to reduce that waste, then we could take the pressure off the land and we could use that spare land for doing other things. Similarly with dietary change, it's very inefficient to produce our calories and our nutrition by forcing them through a 10% efficient heterotroph, that's livestock. Over 30% of all the food that we grow on the planet is actually fed to animals before we then consume those animals and those animal products. From an efficiency point of view, that's crazy. If we can directly consume those plant-based foods directly, then we could reduce significantly the amount of pressure that we put on the land. So there are a number of these things that work together. That frees up land, it reduces the pressure on the land, and it means we can then use that land for other things like afforestation, biodiversity conservation, even producing energy. Some response options are less feasible than others. So some, like bioenergy with carbon capture and storage, at the moment is in demonstration phase, and that needs to be scaled up. We need coordinated action across all of those. And the other thing that's important is the delayed action means that firstly we need to respond more. So if we don't do something now, then actually we need to do more later. But because climate change and degradation are occurring, we're actually in a worse position to realise that potential. So the longer we leave it, the more we need to do and the less the land is able to do in the future. Early action has challenges which is related to technology, upscaling and barriers. So policy could be targeted at overcoming those barriers. And some responses don't address the underlying drivers. So urban expansion is something you can put planning in place to do that. But the underlying driver of urban expansion is the increase in population in some areas. So we can't always do something about that. There are global temperature increases compound the risks, and we've already heard about that one, so I won't speak any more about that. Degradation and desertification and food security, the risks associated with those all increase with temperature, and any development gains we get in some of these pathways could be reversed. So the links through to the Sustainable Development Goals and sustainable development more broadly also make it imperative that we act quickly. I've mentioned the adverse side effects. Policies that address poverty, degradation and emissions can help to produce this resilient, sustainable development that we're looking for in the context of land and in the context of other climate policies. So in terms of the big picture, agricultural emissions are currently sort of largely outside mainstream climate policy, and I think this will be something useful to discuss with the panel in a moment, but they really need to be included. Food and food production and agriculture should not have a get-out-of-jail-free card. Joe showed this morning how important agriculture is in methane emissions and nitrous oxide emissions. We can't just say food should be excluded from this and we have to work in all the other sectors. Just like all other sectors on the planet, we need to start reducing emissions from our food production. We need to act early. We need to measure our progress so that we have a verifiable and reportable and measurable impact. A flexible adaptive approach, an iterative approach is needed. So we can start upscaling by demonstration projects. We learn as we do. We get economies of scale. The unit costs come down. And that's the way that we need to move from where we are now to where we need to be in the future. This is just a summary. Things that I've covered already, the interlinkage, the delayed action, that we need to involve people. This came up particularly for the desertification and land degradation. People are part of the solution, and getting that right is really important. And that will help us to make use of those synergies and also the policies to overcome the barriers. This is the mix of policies. So we need a mix of policies. This is not going to be we make one policy and the whole issue is solved. There are issues to do with land tenure, particularly in developing countries, where there's no incentive to look after the land if you're only looking after it for a year. You're looking after it for your children and your children's children, then those land tenure issues, if we solve those, that helps people to feel their place in the land and to look after the land better. There are some things that can be done voluntarily, like changing diets. Andy mentioned that, the drive towards more plant-based foods. There are other things like awareness generation, using indigenous knowledge, collective action. All of these could be incentivised. There are persuasive mechanisms that could be used. Payment for ecosystem services. At the moment, nobody pays you to increase your soil carbon. Nobody pays you to have an agricultural system which is beneficial for the climate. You could imagine through the cap or whatever replaces it, if something does replace it in the near future. I won't mention the B word, but you could imagine paying land managers, paying farmers for the ecosystem services that they provide, in addition to the food that is produced. And then lastly, there are things like risk-sharing mechanisms which could be used to help to overcome some of the issues associated with food security and some of the pressures put on by climate change. Cheers.
Thanks very much, Pete. If there's one quick question to Pete then this time, yeah.
Hi, thanks very much. Simon Pirani, Oxford Institute for Energy Studies. Many of your esteemed colleagues, different teams, I think at Potsdam, I think saw an article in Nature by Phil Williamson. Others have said that the amount of BECCS included in most of the IPCC scenarios are just completely incompatible with the amount of land that there is to spare. I know from an energy research point of view that CCS, there's no prospect at the moment of it working at anything like the amount of cost, at anything like the level of cost that would be needed for this to work in any way. Isn't it the case that BECCS is basically being used to make those scenarios look better than they are? How would you respond to that?
Yeah, so BECCS is going to be extremely challenging for the reasons that you outline and for the potential impact that it has, the large areas that you need to grow the energy crops, which you then combust and use in BECCS. If you look at the 1.5 scenario, there are some different scenarios of the futures. BECCS happens when we don't immediately and aggressively mitigate across all sectors. That's when we need BECCS. BECCS is the backstop position in a way. That's what we need to do to remove greenhouse gas emissions after we put them into the atmosphere. The best way to deal with it is to not put them there in the first place. Like tipping a cup of water on the ground, then I've got to mop it up. The easiest thing to do is just to put it on the table and not tip it on the ground. So that's what we need to do. BECCS is there. It is a position that could be used, and in some parts, in integrated landscapes, you could do BECCS. Maybe it will be part of the solution, both for energy and for greenhouse gas removal. But if we need it at the scale that we've got in some of those scenarios where we fail to act quickly, then I think we're in big, big trouble.
Thanks very much, Pete. We've got to move on in the interest of time.
Cool.
Thank you. While I'm speaking, if I can invite our panellists to come up, and I will introduce them as they do so. So our three panellists are Dr. Aliénor Laverge,